Assalamualaikum and hello everyone. Today we are excited to introduce our project titled Eco Composite Films from Pumpkin Byproducts.
First of all, let us introduce our team. Our supervisor is Madam Totiana binti Mohammed. I am Farah Nadira binti Effendi, and alongside me is my group member Hani Zalika binti Razak. Let's start with the introduction. Plastic waste is one of the biggest environmental issues nowadays. It takes years to fully decompose. At the same time, agro waste like pumpkin peels and seeds are often discarded despite the benefits in it. So we decided to combine these issues, and an idea to make a biodegradable film by using pumpkin peels and seeds was formed.
For our project, we have three main objectives. The first one is to develop biodegradable films using pumpkin seed and peels as raw materials by utilizing their natural polymer. Second, to evaluate the physical and chemical properties of the produced bioplastic film, especially focusing on biodegradability, solubility, swelling, and tensile strength behavior. And third one is to determine which of the sample with optimal performance characteristic. So this objective guides us throughout the project.
For materials and method, we use pumpkin peels and seed, water, cornstarch, gelatin, and glycerin. The materials were mixed, heated, and poured into molds to dry. We produce different samples using peels only, seed only, and a mix to compare their performance.
So here are the results of our project. Now let's move to the discussion part. So for biodegradability test, on day 1 all the sample appear shiny and firm, which show that they were still fresh. By day 4, the peels and mixed samples started breaking into smaller pieces, indicating that onset of degradation. Meanwhile, for the seed samples, only become softer, which suggests slower degradation. After 8 days, both of the peels and mixed samples fully degraded, while the seed samples was only partially degraded and had turned black. For solubility test, all the samples soluble in ammonia and sulfuric acid. The sample turning dark in sulfuric acid due to its strong oxidizing effect. In contrast, they were insoluble in water, acetone, and ethanol. Overall, all the samples show the same solubility behavior.
For tensile stress test, the mixed sample showed higher tensile stress, which is 13 N per m square, than the peels and seed sample, which are 11 N per m square. The mixed sample performed better compared to the other samples due to it being mixed with a mixture of fibers to create a tighter connected structure, thus resulting in more molecular bonds and a denser, stronger structure. Last but not least is the swelling test. The mixed sample showed a higher remaining mass after being dissolved in water compared to methanol and chloroform. This indicates that the solvent dissolution in water was less effective, whereas in methanol and chloroform, the mass was lower. The mixed sample contains cellulose, lignin, proteins, and lipids. This composite matrix can restrict solvent absorption, particularly in methanol and chloroform. However, due to the presence of hydrophilic components, the sample absorbed more water.
Now we move to conclusion part. To conclude, we achieved all the objectives in this project. We successfully developed biodegradable films using pumpkin byproducts and test their physical and chemical properties. From the result, the mixed sample performed better than the other samples, especially in terms of strength. Looking ahead, we aim to improve the film thickness, texture, and shelf life. Overall, our pumpkin-based eco-composite film is a promising step toward reducing plastic waste through agricultural byproduct.